Okay, so this is AP Chemistry 2005 free response number 1 by Yan Sun and Spencer Su.
Okay, so for the first question, we are given the chemical equation HC3H5O2 becomes C3H5O2 minus and H plus, all aqueous, and we're given the acidic constant Ka equals 1.34 times 10 to the negative 5. Question 1a requires us to write the equilibrium constant expression, which means products over reactants, and so we should get H plus times C3H5O2 minus over HC3H5O2. Okay, so question 1b requires us to find the pH of a 0.265 molarity solution of propanoic acid, and which means we need to do ice, as seen, and we will get a mathematical equation 1.34 times 10 to the negative 5 equals x squared over 0.265. And the reason we ignore the bottom x is because any change from the x would not be negligible. So then we solve for x, we get 3.55 times 10 to the negative 6 equals x squared, and then we get x equals 1.88 times 10 to the negative 3. And then we find pH by finding the negative logarithm of our answer, negative log 1.88 times 10 to the negative 3, and find pH equal 2.725. Okay, so for question 1c, we are added 0.496 grams of sodium propanoate to a 50 milliliter sample of the 0.265 molarity solution of propanoic acid. In part I, we are asked to find the concentration of C3H5O2 minus in the solution, and we assume no volume change. To do that, we calculate the moles of NaC3H5O2, as seen there, and then that will equal 5.17 times 10 to the negative 3 moles of NaC3H5O2, which equals the amount of moles of C3H5O2. Then we divide moles over liters and receive a molarity of 0.103. Okay, so part II wants us to find the concentration of H plus in the solution. Again, we need to do ice with the 0.103 molarity of C3H5O2 minus in the initial, as seen there. And once again, we have to remove any added x's to the numeral values, as any change would be negligible. And so we get the equation 1.34 times 10 to the negative 5 equals x times 0.103 over 0.265, which means x equals 3.45 times 10 to the negative 5.
For part D, the methanoid ions HCO2- reacts with water to form methanoic acid and hydroxide ion as shown in the following equation. Part D, given that OH- is 4.18 times 10 to the negative 6 mole in a 0.309 mole solution of sodium methanoid, calculate each of the following. So first, we do ice, which we will get Kb equals OH- times HCO2H over HCO2-. Since we got the concentration of OH-, we can say it is equal to the concentration of HCO2H, and HCO2- is equal to 0.0309, which we will get the Kb value equals 5.65, and then we need to calculate the Ka value. Ka is equal to K water over Kb, so which is 1.00 times 10 to the negative 14th over 5.65 times 10 to the 11th, which is what we got in the previous question, and the answer is 1.77 times 10 to the negative 4th. Part E, which acid is stronger, propanoic acid or methanoic acid? Justify your answer. The stronger the acid is, the lower the pH value it is. So we are able to know that Ka for propanoic acid is 1.34 times 10 to the negative 5th, and Ka for the methanoic acid is 1.77 times 10 to the negative 4th. So therefore, the larger value of Ka, the greater the strength, and the methanoic acid is the stronger acid because 1.77 times 10 to the negative 4th is greater than 1.34 times 10 to the negative 5th.